Mabuhay! For today's video, we are going to show you how to make an improvised alcohol thermometer. But before that, let us first discuss what is a thermometer. A thermometer is an instrument that measures temperature. The mechanism of a thermometer was based on the principle of thermal expansion and contraction, which states that when a substance gets hotter, it expands to a greater volume. Moreover, as the temperature of a liquid inside the thermometer increases, its volume also increases. Notice that the liquid in a thermometer is enclosed in a tall, narrow glass or plastic column with a cross-sectional area. In line with this, the increase in volume which results in the increase of height of the liquid in the column is directly proportional to the increase in temperature. On the other hand, a decrease of temperature results to the decrease in height of the liquid inside the thermometer. Temperature measurement using a thermometer is important in a wide range of activities, including medical practice, laboratory experiments, and scientific research.
Objectives. To be able to create two identical alcohol thermometers, to calibrate both thermometers using the freezing and boiling point of water as reference points, to design and conduct an experiment that can be used to explain the occurrence of land breeze and sea breeze using the improvised thermometers. And lastly, to explain the science concept involved in the operation of thermometer. Materials. Improvisation time!
Now, let's start improvising our own alcohol thermometer.
Add an adequate amount of alcohol to the bottle or fill it about halfway up. Add a couple drops of food coloring to the alcohol. The clear drinking straw will become the narrow tube of your thermometer. Use a permanent marker to make small marks with a measurement of 0.5 inches based on the standard mercury thermometer. Put the straw inside the bottle. Adjust the straw so that the end is immersed in the liquid but does not touch the bottom of the bottle. If the straw touches the base of the bottle, the alcohol won't be able to travel through it and your thermometer won't work. Use the modeling clay to seal the bottle opening and to hold the straw in place. Make sure that the clay forms a tight seal around the straw and over the bottle mouth, but don't close off the straw's opening. Label the water level at room temperature. Look for the liquid level inside the straw and use a permanent marker to draw a line on the bottle. Take a reading from a standard mercury thermometer to find the actual room temperature. Write it down next to the line on the bottle. Set the improvised thermometer in a container of hot water and label it. Fill the bowl large enough to hold your thermometer with hot water. Put your improvised thermometer and your standard mercury thermometer in the bowl and watch the water level rise in the straw. Once the level stops moving, make a line on the bottle or straw with a marker and label it with the actual temperature of water using the standard mercury thermometer. Test your improvised thermometer in cold water and mark the bottle with temperature. Put the improvised thermometer and the standard mercury thermometer in another bowl with cold water. Notice how the water level in the straw goes down the longer it is on the water. Once the level has settled, label the actual temperature of the bottle using the standard mercury thermometer. You can make another improvised thermometer so that it is easier for you to measure temperatures of different substances or location. One situation in which you can use two improvised thermometers is on the concept of land breeze and sea breeze, which will be shown in our next activity.
Activity time!
Measure the initial temperature of the setups, the sand and water. Note the initial temperature of the setups within 5 minutes. Place the setups for 3 hours in an open area with direct sunlight. After exposure to direct sunlight, record the final temperature of each setup. Finally, compute the difference between the initial and final temperature. The temperature differences between land and water that creates a distinctive wind pattern is an example of thermal circulation. The differential heating and cooling of adjacent land-water surfaces leads to the development of land and sea breezes. Let us consider that water has a greater heat capacity than land and absorbs and emits radiation faster. As the name suggests, the two breezes occur in coastal areas or areas with adjacent large water bodies. Water and land have different heating abilities. Water takes a bit more time to warm up and is able to retain the heat longer than the land does. In the day, when the sun is up, the land heats up very quickly and the air above it warms up a lot, more than the air over the water. The warm air over the land is less dense and begins to rise. Low pressure is created. The air pressure over the water is higher with colder dense air, which moves to occupy the space created over the land. The cooler air that comes along is called sea breeze. In the night, the reverse happens. The land quickly loses its heat while the water retains its warmth. That means the air over the water is warmer, less dense, and begins to rise. Low pressure is created over the water. Cold and dense air over the land begins to move to the water surface to replace the warmer rising air. The cool breeze from the land is called a land breeze.